recording. As as you know, we're trying to record all of this to publish this in our YouTube page for our people that might might be willing to see this afterwards, to watch the recordings. So again, I repeat myself for the ones who were before. I'm Luigi Belli, the Director of Events for PMI Belgium. And today we are joined by our colleagues of Cognilytica that are going to present us their best practices on how to run successful AI projects and avoid failure. So I think now we're good. We do have people that keeps joining, but well, the floor is yours. Kathleen, Ron, you can just start.
Okay, great. Well, thank you so much for inviting us to present today. We're really looking forward to this. And we want to share about how to run successful AI projects and avoid failure. A quick introduction, just so that you know who we are. I'm Kathleen Walch. I'm a managing partner here at Cognilytica. We're an AI-focused research, advisory, and education firm, and we have been around for a number of years now, since 2017, really pushing best practices around AI projects. Ron and myself are the co-creators of the Cognitive Project Management for AI, the CPMAI methodology. We built this in conjunction with a large bank and government agency, which we'll talk about later. It's been around since 2017, and it has broad adoption in both public and private sector.
Yep. And Ron Schmelzer, also a managing partner and here at Cognilytica. And again, I want to thank you all so much for joining us. And a reminder, this actually is for you. So, if you have questions or comments, please do enter them. I'll be keeping an eye on your feedback here so that we address them as we go along, especially some of you may have some feedback on the things we're presenting. So as Kathleen mentioned, we're co-creators of the CPMAI methodology. We've been writing and covering and focusing on the AI space for well over a half decade, going into our 7th year, actually. We are the co-hosts of the AI Today podcast. We were just talking about that before we started here. And we have over 400 episodes. We always talk about how is AI impacting things right here, right now, today. So that's really very important. We also write for Forbes on the topic of AI and Tech Target. And Kathleen was actually very recently, well, a little while ago, was in Paris for the OECD's One AI Working Group. And that'll come in really handy when we talk a little bit about that shortly. And we'll understand what happened when we went to Paris and shared the 7 patterns of AI. Also, you'll find us sort of major contributors on LinkedIn and write a lot about the topic of AI. So enough about us. Let's get into what we're here to talk about.
Yep. And then one more quick thing about questions. We encourage you to type questions as they come into your head throughout the presentation. And then, like Ron said, he'll address them as needed if it's about that slide. Otherwise, we'll hold all questions until the end. But we have definitely set aside time for questions. And we love when the audience is really interactive and engaging, that we know what's resonating. All right. Whoop.
Yep.
There we go. It sometimes is delayed for me on my end, so apologies if you see that again. So AI projects, what we've noticed when we've looked at them over this number of decades is that there really is a high failure rate to AI projects. The numbers vary, but on average, it's about 80+%. And we say, why is this the case? Yes, we understand that projects are going to fail, but why are these AI projects failing at such a remarkably high rate? And is this, more higher than traditional projects? And what could be causing this? And so as we've looked at all of these AI projects, we find that there really are some common reasons why AI projects fail, and we want to address them with you so that you yourselves don't make the same mistakes.
So part of that is that we've found a number of common reasons why AI projects fail. And actually, let's go to that next slide there. And that one of those common reasons that we've sort of grouped them together. And also what you'll find in this presentation is that we'll bring some real world examples to show that it's not just, edge cases, but they're actually very common. And one of the most common reasons why AI projects fail is that they're not really traditional or typical technology, software development, or IT projects. when we have a typical IT project, we can have some functionality that we're building for a website, a mobile app, an enterprise software application, you name it. We have some deliverables, we have some functionality, we build it, we test it, we deploy it, and if it works, it works. And sometimes we even are using legacy applications we built decades ago, right? That's actually part of the problem with IT. And we're so dependent on them that they're not changing. And so the traditional application development cycle is focused on building these things for deployment. The problem is that AI applications don't work that way. The whole idea of AI, like the reason why we want intelligent machines, is to handle variability, because otherwise we just program it. Why do we even need AI? Well, we need AI because we want to handle these problems that we can't easily program, whether they're conversations or image recognition or autonomous systems. We'll get into some of these ideas shortly here. And so because of that, these AI systems are so dependent on data that what works today probably won't work tomorrow. Even what works today might not probably always work today. We are dealing with the fact that AI systems are probabilistic, but we are building them as if they are not probabilistic. That is, if we can deploy them and have fixed development time cycles and fixed functionality. We have a chatbot, we deploy the chatbot, and it just works. But that's never the case with AI, and that's why a lot of projects run into this hard wall of failure. But part of it is also, as we're hinting here, is that not all AI applications are really the same. AI may be a term, but it really covers a fairly broad set of things that in some cases don't have a lot in common with each other.
Exactly. And so when two people talk about AI, they may not be talking about the same thing. AI really is an umbrella term. So I may be talking about image recognition applications. Ron may be talking about autonomous vehicles. Somebody else may be talking about AI-enabled chatbots. All of them fall under that umbrella of AI, but they really are different applications of AI that may require different data, different algorithms, different return on investment, different timelines for full project completion. So what we did a few years ago is we said, all right, let's break this down one level deeper and say, yes, this is an umbrella term of AI, but let's break it down one level deeper. And what are we actually trying to do? And this is where we came up with the 7 patterns of AI. A few years ago, as Ron mentioned, now back in February of 2020, right before the world shut down for the pandemic, I went to Paris to present at the OECD, the Organization for Economic Cooperation and Development, on the 7 patterns of AI, which they have then adopted as their definition of AI. Despite the term being around and officially coined in 1956, there is no commonly accepted definition of AI. So the OECD is trying to change that. And recently, the EU AI Act was passed, and they have used the 7 patterns of AI as their common definition of AI as well. So it's important to understand this at a high level and why it really matters. So it's a wheel because no one is more important than the other. And at a very high level, hyper-personalization is where you're treating each individual as an individual. The recognition pattern is making sense of unstructured data. So we think about image recognition, for example. The conversation and human interaction pattern is machines and humans interacting in human language. Chatbots are a great example in that. Predictive analytic and decision support. This is taking past or current data and helping humans to make better decisions. We have our goal-driven systems, which is really around reinforcement learning, and it's finding the most optimal path to a solution. We have autonomous systems. So the goal of this pattern is to remove the human from the loop. A lot people will think about hardware and they'll think about, autonomous vehicles, for example, but this can also be applied to software, and you can have autonomous software systems, optimizing and navigating through your company, through your network. And then we also have patterns and anomalies. So machines are really good at looking at lots of data very fast and being able to spot patterns in that data and also spot outliers in that data. We think about fraud detection, for example. So at a high level, this is the 7 patterns of AI. And it's important to understand because it helps you break things down one level deeper, and it also helps you shortcut your way to AI project success.
So one of the things we noticed with AI projects also is that one of the interesting things with AI is people feel like they need to do AI, even if they don't have a strong business driver to do so. There's a strong fear of missing out, FOMO component to AI. Also, because AI is this general term, but we know that we're actually talking about very specific and in some cases very different applications. Somebody in the senior management say, we need to do AI, that may get interpreted as something very different, lower level, who may say, they said AI, but they mean a chatbot, right? Or they mean an image recognition system, right? Or maybe they mean this really complicated autonomous robot. And because there's this, difference in level of abstraction, we have this problem where the project has an investment and then it's at such a level where the return is not justified by the complexity of the project. So as we like to talk about here, always start with anything. Doesn't matter what the technology is. It could be AI, automation, a website, a spreadsheet, whatever it is. You have to start with the problem you're trying to solve, right? What is the problem we're trying to solve? And in the case of AI, it has to be a problem that has AI as the correct solution rather than some other thing which may not be best suited for AI. So we might be thinking, okay, well, we want a return from whatever it is. So are we trying to say save some costs? So we're going to use AI to say replace something that has a high, human load to it, and we want to do something that we couldn't do otherwise with any other method, like programming or process or something like that. Are we trying to save time? Are we trying to save some sort of resource, a financial cost, some other resource we're trying to use? Are we trying to improve some compliance that may be difficult otherwise? Maybe we're going to do some automated reporting, recording, transcripts, whatever we're going to do. Are we trying to improve satisfaction? Once I know the problem we're trying to solve, then I can look to the patterns of AI and say, okay, which pattern of AI has the chance, or patterns, maybe multiple, to solve this problem in an AI way? And if I can't identify the pattern and I can't identify the problem, that's a very strong hint that maybe AI really isn't the right fit for it. There may be a better non-AI alternative. And in some cases, well, we'll get into it a little bit here, but we'll show you an example of what happens when things go wrong, when people haven't thought about the patterns they're trying to solve before they go ahead and build something, right?
Exactly. And another thing that we've seen too is you may have noticed automation is not one of the 7 patterns of AI. There's autonomous pattern, but that's different than automation. When you automate something, it's repetitive. It's going to be the same exact way every single time. And a lot of people confuse that automation with AI. I think about, I automate my coffee maker to brew at the same time every single morning. There is no intelligence there. If I forget to put water in the coffee pot, it will still try to brew. If I wake up much later in the day, it will still brew at the same time that I have set it. So we need to make sure that we understand that difference, and that people can fall in love with AI, like Ron said, until they fall out of love with AI because they realize that maybe that return on investment with all the money and time and resources that they put into it didn't actually work. So we like to have these ripped from the headlines in this presentation, because it's one thing for us to say we've seen AI projects fail, but it's another thing for it to actually be published and say, look, these very large organizations with tons of resources and smart people are still failing. And we want to highlight that for you so you understand why this happened and don't make the same mistakes. Walmart is a very large retailer. They had a robot that was scanning store shelves to do things like check on inventory. And if inventory was low or out, it would notify a human who could then go and restock it. What they found is that it just didn't have that ROI that it was looking for. And so it ended up canning the entire project. And this was not a cheap project. You think about, they needed to have this autonomous pattern, right? They needed to have a robot that was automatically scanning the store floor. And then it was also doing the recognition pattern. It was looking at the shelves to see if things were out of stock. What Walmart could have done is started smaller and not tried to combine so many patterns of AI together at once. And they instead could have had a human who was already walking the store shelves push a camera on a shopping cart so that it was able to check all of the inventory. And that it would still be, getting a benefit because it would be being able to check all of the store shelves maybe faster than a human, but it wasn't combining all of those patterns. And so then it wouldn't have failed in such a large way.
So one of the other problems that's sort of inherent with AI is that because AI is the machine learning component of AI specifically is about learning from data, learning patterns from data, and then trying to apply the learning to future data it hasn't seen before. That's sort of the fundamental explanation of machine learning. So we have these issues at the same time. On the one hand, we need to have good quality data because bad data returns bad results. On the other hand, we need to have a sufficient quantity of data because not enough means we don't have enough data points from which to learn. But it turns out that it's not as simple as just collecting as much data as possible and just training the system on as much data as possible. Because on the one hand, as mentioned, we have this garbage in, garbage out problem, is that sometimes we are collecting the wrong data, or maybe we don't understand what data we need, or maybe we don't have access to the actual data we need, and maybe we can't have access to it because maybe it's private protected data. Maybe it's secured. Maybe we're not allowed to make use of that data for regulatory and legal reasons. And so we have to, if we don't have access to it, and we need to say, build a predictive health system, and no one's giving us access to actual patient data, then the best we can do is make some sort of approximation or use synthetic data or things like that. But we know inherently that's going to have some limitations. And so that means that it will impact things like accuracy. And sometimes we charge ahead with the project before we've factored those things into account, and we run into these major issues. There's also the issue with data quality. We know that the data is never as clean as we want it to be. It's got missing information, incorrect information. Maybe it's aggregated in a way that it's too aggregated. We need it to be less aggregated, or maybe it's not aggregated in a way we want it to be aggregated. There's lots of challenges here. So we know we need to clean the data. So if you think about the two things I just said, they're actually somewhat at odds with each other. I need to collect as much data as possible to train the system, but I also need to clean that data. That means that the more data we have to collect, the more work we have to do to clean it. And it doesn't even scale linearly. If I say, well, I have a gigabyte of data to use to train a model, well, I need to clean a gigabyte of data. But if I say I need a petabyte of data, I have to actually clean a petabyte of data. That could in itself be a whole project. That could take months. That could take who knows how long, right? That could cost a lot of money. And if you haven't properly aligned your budget and your resources, you may not have the resources to do it. So there's lots of impacts that happen when we have bad data in our AI systems. I think we all have seen it, but we'll share some of the headlines anyways.
Exactly. So a few years ago now, it has come out that ImageNet, which is a large database of images, is riddled with errors. They say maybe about 5% or so of that training data is flawed, which is quite a large number when you think about how big that data set is. So the image that we have here is a deer, but it was mislabeled as a magpie, which is a small bird. And this can be hard to identify if, that your data is actually mislabeled until things like this come up and you're like, why is this deer being labeled as a magpie? Another example that we have is a lot of people are figuring out ways that they can use generative AI to help them create a whole bunch of things, one of which is books. And on the surface, that sounds like a great idea. But what was discovered was that if anybody here, forages and goes out into the wilderness and tries to identify and pick food, you'll know that there's food that you can eat and food that you shouldn't eat, especially when it comes to things like mushrooms, where some can be quite poisonous and others are not harmful. And these books were being written by AI, and people found out that the mushrooms that they were recommending you to eat actually were the mushrooms that were poisonous and you shouldn't be eating. So you do really, need to be careful, especially because if people are out in the wilderness, they probably don't have access always to the internet, and they're going to be bringing a book out to use as their source. And then another retailer in the United States, Rite Aid, recently got into a lot of trouble, and they've been banned from using AI facial recognition after the FTC said that the retailer just deployed the technology without reasonable safeguards. So for a number of years, they were using AI to identify individuals that walked into the store and flagged them as potential shoplifters. And they found out that it actually was very riddled with errors. They didn't have good data quality that was going into these systems. And they also did a number of things like not sufficiently training their employees. So they weren't able to actually handle the results that they saw. We always like to present these ripped from the headlines because it is very real and it continues to happen. And so we want to point it out so that you understand what's going on so you don't make these same mistakes.
So,
So also a few years ago now, we published research talking about what was the percentage of time that was allotted to AI projects. And what we found was that 80% of AI projects are data engineering projects. So it's all about the data, right? Data identification, aggregation, data cleaning, because we know that our data is not going to be in a good usable state right away. Also potentially labeling that data and augmenting and enhancing it in certain ways. Only 20% of the project is really that, quote unquote, fun stuff of picking our algorithm, training it, fine-tuning it, and then putting it out into the real world. So if 80% of our projects are data engineering projects, that just goes to show how important data is, and especially that data quality and data quantity issues.
So another sort of issue we have that is with many projects, many of these problems are actually not specific to AI. Some of these can be applied to even non-AI problems, and this is actually one of those as well, but has a unique AI failure mode, I guess is the best way to put it. And this is idea of the proof of concept trap. So the thing about AI systems, especially now with generative AI, when so much is available, to people to just do off the shelf, people are very tempted to just do things with AI and just try things out. That's what the proof of concept is, just try things out. The problem is that, as mentioned, AI systems are very sensitive. They need access to the real world data, and trying something in a controlled environment doesn't actually really prove anything. I mean, we have that's what researchers do all day. The research mentality is really about proof of concept, trying things out, experimenting with new methods and seeing how that works. However, when we're doing things in the real world, we really have to focus on pilots because we need to see how does this model actually work with real world inputs? How does it actually provide the real world outputs? Is it consistent? And the challenge here is that a lot of times people are just spending way too much time. We've talked to people who have a 12-month or an 18-month AI project. We're like, do you even know what happens in the AI world in 12 months? A lot, right? AI projects need to be very short, very quick. They need to be weeks at most for each AI project, which means that we need to scope the project. Now you know about data quantity and data quality, which means we need to actually reduce the amount of data that we're working with, because the more data, the more problems, the more time we need, right? Now you kind of see how all these things go together. It also means, hey, maybe we should only tackle one pattern at a time. And maybe we should tackle the pattern that will provide the quickest return, not necessarily the pattern that will, I don't know, have some huge long-term impact. We'll talk a little bit about how to balance these things out. So proof of concepts are really very easy, and they don't really prove very much because we've already proven AI at a conceptual phase. So the real thing is, how does it actually work in the real world against real problems? And when it does, that's how we know if we're being successful. And also, if it's not, we know much sooner than waiting till the end of 12 months before we have to cancel yet another big AI initiative.
Exactly, because no one's going to be happy that you've spent all that money, time, and resources on the project just to have it fail. So we are big advocates of pilots. Another common reason that we see AI projects fail is that the real world doesn't always match your model. And that goes into why we say do a pilot, because the real world can just be messy, right? And it's going to be a lot messier than our training data. Usually when we're training our AI system, we feed it the best data that we have, and we know that it's clean and it's good data, it's labeled if it needs to be, and it's properly labeled. But when we get out into the real world, data isn't always like that. And AI models are very sensitive to all sorts of inputs that maybe you've never tested for. And so because of this, AI models can and most likely will fail in some pretty extraordinary ways once you actually have it out in the real world. So that's why we say, if you're doing this proof of concept, it's not really going to be proving much. But if you have it in a pilot and you're out there in the real world, you're going to see some of the real issues with it. Also, it's going to be used by people that haven't trained that and are so, widely intercoupled with that. So it's important that we see how is it being used in the real world. People, even AI luminaries in the space, are still making some of these errors because we find that AI implementers often skip some real model evaluation steps. This can be done for a number of reasons. Maybe they feel pressured to get something out. They don't think it's a big deal to skip this step, but it actually is. And so Andrew Ng, who is an AI pioneer and luminary in the space, has a real world example where he used a very high tech system at Stanford Medical to build a model for radiology images, for being able to screen radiology image with an AI system. And what he found out was it turns out that when you take that same model, that same AI system to an older hospital down the street with an older machine, and a technician uses a slightly different imaging protocol, that data drifts to cause the performance of AI systems to degrade significantly. In contrast, any human radiologist can walk down the street to the older hospital and do just fine. So if they had tested this maybe to begin with on that older system at the older hospital down the street, or brought in a bunch of different technicians who all had slightly different imaging protocols, they would have been able to see this in their pilot. And that's why it really is so important that we do them.
Mm-hmm. And I think this also brings up sort of the next failure mode, is that people don't realize that AI systems are constantly changing. If you've been working with any sort of generative AI system, you might have noticed that what may work today may not work tomorrow. Even the very same prompt may not work the same way. In some cases, it's because the generative AI systems are changing their moderation. That's a human-based factor. But in a lot of times, it's because of what's called model drift and data drift. So getting into that. So as we know, AI systems are trained with data, but data is constantly changing. And I think the other sort of nature of it is that as we start increasing the population that interacts with an AI system, we get more edge cases. And I think the thing about edge cases is that's where AI systems, that's where they sort of prove their mettle. Because if things are happening in a very predictable way, then we may or may not even need AI, because if we know that everything's going to come in the same way, then I don't, if I want to have an interaction with a customer about their questions about, say, some policies, or they have some issue of maybe some customer support, this will come in very handy in this example we'll provide today. I could just have a website with an FAQ section, or a website with a bunch of, and that's deterministic, because I'm going to ask the questions and I will provide a very well thought out answer. But if I replace that with a chatbot, what's going to happen is that it's going to go from being deterministic to probabilistic, because people don't ask the same questions the same way. I need to generate responses from the data, and those responses might not be the same every time. And what's going to happen, not 100% of the time, not 0% of the time, but some percentage of the time, there will be a mismatch between what I want the system to do and what it actually does. And what it actually does may not be in my best interest. So what ends up happening is that people tend to just set the chatbot out and just say, okay, we're done. It's up, not realizing that they actually need to be constantly monitoring and managing it. With AI, there's no such thing as set it and forget it. It's just like your own brains. You don't set and forget your own intelligence. Why would we set and forget artificial intelligence? Right.
Exactly. A great point. So with our rip from the headline example here, very recently, Air Canada was brought to small claims court, and they had to honor a refund policy that the chatbot had made up. So a user went in there, and it was for a bereavement flight, and they asked the chatbot on Air Canada's website what the policy was, and the chatbot pulled up a policy, they screenshot it, and then they went and they booked their ticket, only to find out that Air Canada said, hold on, our website doesn't say that, and our website is authoritative, so we don't care what the chatbot said. we go by the website data, but that was never disclosed to the user. So this is why we say it's never a set it and forget it, because you constantly have to be monitoring what is in your systems, and for, in this case, the output that the chatbot is producing. Especially if your website is getting updated, you need to make sure that that data is getting updated into the chatbot as well. You can't have conflicting policies and then say, well, yes, I understand that the chatbot on our site said that, but the website says different, so we're going to go with that. There was also another recent example about a car company, and someone went on and said, can I buy this car for $1? And the chatbot said yes. And so then they tried to bring it to a store to buy that car. And they said, no, we're not selling this to you for $1. So you can get into a lot of issues, legal issues, and a lot of trouble as well. So we always say, make sure you understand that AI projects are continuous. It is not a set it and forget it, and that your data is going to drift over time, your models will drift over time, and you need to constantly be monitoring this. Another common
go ahead. Yeah.
reason that we see AI projects fail is that people get either they fall in love with a certain vendor, or they get caught up in the vendor hype, and there can be product mismatch and overhyping and overselling of what solutions can actually do. And we get this. People get really excited and they really want to push forward with what happens. But we say, take a step back and don't fall for that vendor hype. Really make sure that you understand what you need and get a solution that fits that. Going back to the 7 patterns is a really great practice here, and say, what pattern or patterns of AI am I trying to solve? And does this solution help me with that? Sometimes there can be vendor misalignment because what they promise and what they deliver doesn't always match. They can overhype things, they can oversell, they can overstate what it can do. And sometimes organizations also say, well, we are vendor X shop, and you insert whatever vendor that is. Maybe some of you have experienced that yourself. And so organizations say, just see what solutions that vendor has, because that's who we're going with. That's who we're already integrated with. And that isn't always the best answer when it comes to AI, because it might not actually, maybe a really great solution. It's just not the great solution for your problem. We always say, don't try and fit that vendor square peg into a round hole.
Yeah, and a good example of this is that right now, it seems that generative AI is a solution for every problem, which is really interesting. I think it's because it's just so available. People can, get online and use all these systems. And also, all the big vendors are competing with each other right now. They all want to be your platform of the future. And I think if you haven't observed this, maybe I'll call this to your attention, that everybody sees that AI is the next platform that everybody wants to win. So Microsoft wants to be the winner, Google wants to be the winner, Amazon, IBM, OpenAI, they all want to be that winner, right? And they know that if they can get you on their model, on their platform, then that'll help lock you in basically to the next set of features. The thing though is that you can't use generative AI for everything. You can't use these models for every problem. It's even worse than making AI a solution to every problem. It's a very specific implementation of a very specific pattern. This is just the conversational pattern of AI. Maybe a little bit of recognition, maybe a little bit of pattern and anomaly detection, but it's really mostly, you can't use generative AI to drive cars. You can't use generative AI to do robotic surgery. You can't use generative AI for all those things. So it's a very particular application, but people want to use it for everything. I can't tell you how many times I have to smack my head when I say, I asked GPT a math question and it got it wrong. And I'm like, asking GPT to solve a math problem is like asking a dictionary to solve a math problem. You don't understand what the tool is for. It's a text prediction tool. It doesn't even understand that the number is a number. It understands the number as a word, and so it tries to predict what the next word should be. Very odd applications. And we tell people, I think it's because they see it and they want to use it for everything. So what we tell, this actually can cause whole companies to fail. Not too long ago, IBM had Watson and Watson Health, and they were pushing it as their big strategy for solving healthcare problems. The problem is that these are very difficult problems to solve. They hadn't even proven that that AI was a good solution for any healthcare issues, but they banked their whole company on it. and this whole organization, this whole part of the company, and it actually failed. They actually had to kill IBM Watson Health, and they sold it off. And it's a lot of that's going to happen. I think with a lot of generative AI solutions, people are putting an AI into everything. It's not going to deliver on every promise, which means that some companies are going to probably not be around tomorrow that are around today. So I would say don't get caught up in that hype. Understand that every problem has its optimal solution, and that there are different ways of tackling each problem.
So another reason that we see AI projects fail is this idea of the uncanny valley. So if you're unfamiliar with uncanny valley, it's a relationship between the degree of an object's resemblance to a human being and the emotional response to the object. This is around physical objects, for example. So not sure if any of you are familiar with the Sophia bot that came out a few years ago, but this was a, robot that was able to have facial expressions and talk like a human, but they did not put hair on her because they wanted you to know that it was a robot. So sometimes, when these humanoid objects appear almost, but not exactly quite human, it makes us feel very uncomfortable. And this is when we dip into that uncanny valley. We also have a data version of the uncanny valley, and it's important to understand this because as organizations are collecting more data on individuals, whether that's users or that's customers or employees, there's a trade-off where you want to be providing value, but you don't want to go into that uncanny valley where now people say, hold on a minute, you know too much about me. I don't feel comfortable with this anymore, and I don't feel comfortable using your system or using your product or being a customer anymore, and they stop using it. And once you fall into that uncanny valley, it's very hard to pretty much impossible to come out of that. And that's why you need to be mindful of this. And unfortunately, that line that, where you dip into the uncanny valley is different for every single person. So you as an organization and whatever it is you're doing need to say, okay, how can I get right up to that line, but not fall into that uncanny valley?
Another way of thinking about the uncanny valley is creepy. People think it's creepy, right? And you could say something is creepy either physically or even with data. It's just creepy that you know this much about me. And I think as AI systems start to build more of these profiles, more of these sort of details on people, this is actually where the EU AI Act comes into play in some cases, because they know that it's very hard to get out of that line. When a bank or a healthcare company or an automotive company or a food company or any retail, when they know more about you, that means that they can say, hey, I could target this thing for you at this exact time, or I could change the rate. I could do this predictive pricing thing, charge you more for something, charge less to someone else. And they know that it's a very seductive thing to leverage a data advantage, because the person who has the data has the advantage. The person who doesn't. It's the new he who has the gold rules, right? The golden rule. So we'd say, when you're trying to build a successful product, when you're trying to make an AI project successful, when people say, I'm not going to use this anymore, they just go, don't use this at all. This is the conversation happening right now with TikTok, actually. Then people are going to just try to avoid it, get it banned, and you don't want to be on the other end of that. So anyway, there's a lot of ways of figuring out how close you are to that uncanny valley. So, one of the big fundamental reasons in general why AI has fails many times is because of this idea of overpromising and underdelivering. Just on the idea of AI, when we have been here so many times before, many of you may know that AI, as Kathleen mentioned, is not a new thing. We like to call it like the oldest new technology, right? AI has been around since the 1950s. As a term and as things we've done. We've been through two previous cycles of hype with AI. In the 1950s and 60s through the early 1970s, we had that first big wave of AI. And then that crash when people realized that we couldn't do everything we thought we could do with it. That was what's called the first AI winter. Then we had another surge of interest that kind of was around when Deep Blue was playing chess with Garry Kasparov and expert systems. You may remember those. There was a big wave of interest there in the 90s, early 2000s, but then There was a trough there because people realized, again, it didn't do what we thought it was. Here we are now in this new third wave. Will we stay? Will there be another AI winter? I think that's the question, right? I think someone's basically unmuted. So if you can mute yourself, let us know. And so one of the things that we want to focus here, you on, is that don't overpromise what AI is capable of doing. And when that happens, we end up with some really bad things. When we trust AI too much, that it can do too much, right? We need to ask ourselves these questions like, why are we using AI for this problem to begin with? Are we promising too much about what this AI system can do? Maybe it can't really do it. Are we more invested in the AI part than in solving the problem? Do we even know what problem we're trying to solve? Sometimes we don't. What problem is self-driving solving? I mean, let's just be honest. What is the autonomous vehicle problem? Like, it's cool that cars can drive themselves, but what problem is caused by cars that can't drive themselves? It's actually a pretty deep question. You may actually realize that maybe it's not actually solving any problem. Do people not want to drive their cars? I don't know. Maybe some cases, but is that the majority of the cases? I don't know. They can get on a bus or a train. There's lots of ways of getting somewhere without driving. So I think it's a very rational question. Maybe we're more invested in the solution than in the problem. And are we tackling the hardest problem first? Because some of these problems are very, very difficult to solve. And if we invest too much in solving that hard problem and we can't solve it, people will just throw it all out, say AI is not good because it can't solve this very hard problem. So we have some examples here. We'll talk about what it means when we overpromise. We'll bring up the self-driving autonomous vehicle case here.
Yes. So a few years ago, you may have heard, a lot of different companies were really pushing forward with autonomous vehicles, and you need to obviously be testing these on the road. So Uber was moving forward with autonomous vehicles, and yes, they had a human behind the wheel, but the car was in fully self-driving mode. And there was a pedestrian that was crossing the street outside of a crosswalk and walking their bike across the street. And unfortunately, the car hit the human and she passed away because of her injuries. So we need to say here, okay, were we overpromising and then under-delivering on what we said we could do? Was this car really able to be in fully self-driving mode right now? And yes, there was a human behind the wheel, but the human wasn't notified until it was too late to take over. And also, we know as humans that we are not always good at making, very fast decisions in a split second where they need to take over and then, automatically brake or whatever. You need to be processing that as well. And so the human should have been paying attention to the road and had their eye on this, but they didn't. And so we have a whole podcast on this, and I encourage you to go to AI Today podcast to check it out. We cover all of the different angles about who was at fault, why this happened, and how it could have been prevented. So if you're interested in digging deep into that, I definitely encourage you to check out the podcast we have on that. But really, at the end of the day, we want to be making sure that we aren't overpromising and then under-delivering on what we can do, because as Ron mentioned, this is what's brought us to AI winters of the past, which is a period of decline in investment and popularity with AI, and we do not want that to happen again.
So fortunately, there are ways of addressing these very common failure modes. So maybe it was implicit in the way we were explaining it, but I'll make it more explicit. And that is that technology is a tool and technology is useful. However, technology by itself cannot solve these problems. We can't solve the problem of overpromising or data issues or life cycle issues with more technology, right? We need other things. And those other things that we need people and process. We need approaches, just like when we moved in the Industrial Revolution and we moved to automation of factories. Yes, a lot of that was technology, but we also revolutionized the way that we manufactured things. We revolutionized the way that we delivered things, that we did customer support. Same thing, we're at this point with AI, where it's like the technology is good, but we can do good things or bad things. We can have good use cases. We can have good outputs, or we can have bad outputs. So what we really need is we need a methodology. We need a framework by which we could put these highly probabilistic systems into place that's highly iterative, that's data focused and data driven. And it really starts with the first fundamental philosophy, which is think big, start small, iterate often. That's not even an AI thing. That's just an iterative, agile way of thinking, right? But what is unique to AI is that we need to be focused not on functionality, but we need to be focused on data. And we need to be focused on probabilistic outcomes. So this sort of brings up how CPMAI came about, because a little over a decade ago, we were working with some major banks and some major government agencies who are putting AI into practice in some very high risk situations. And they said, we have the technology, but we just need a methodology, a pattern. And there wasn't really anything out there. I mean, the only thing that was out there was something called CRISP-DM, which some of you may be familiar with, which was a data-centric methodology for data mining. But it had not been evolved. Nothing had happened since 1999, pre-dot-com, crash. It's kind of interesting. And we're like, it has a lot of the good elements. It says, like, here's how you basically build data-driven systems and do so in iterative ways. But it didn't have enough information about handling probabilistic systems, which are AI systems. So a little over, as mentioned, a little over half a decade ago, we worked with these organizations to build on top of CRISP-DM a methodology that was AI-centric and data-centric called CPMAI. We'll get into that now.
Exactly. So CPMAI has 6 phases. They all are iterative. And to go through, one phase really should be taking about 2 weeks. We don't want our projects, one iteration of this, to be going on for months. That's just way too long. So at a high level, phase 1 is business understanding. We need to be asking what business problem we're trying to solve. It may sound simple, but a lot of people move forward without asking this question. Within the business understanding phase, then we want to be understanding our AI business requirements and KPIs. We also have an AI go, no go, which is a series of 9 questions, and we like to think of them as a traffic light. So you have green, which is if all of them are answered yes, then it's green and it's good to go. But if some are yellow, it's caution, or red, then we say that doesn't necessarily mean you can't move forward with your AI projects, but just know that if they're not all green, then your chance of AI project failure will be higher. And then we also have trustworthy AI requirements that we want to be addressing in phase 1 as well. This has come up a lot, especially in the past year or two, about people wanting to build trustworthy and ethical and responsible AI systems. So we make sure that that's addressed in CPMAI as well. Phase 2 is now around data understanding. So we say, okay, great. We know what business problem we're trying to solve. Now we can move to our data. We know that data is incredibly important for artificial intelligence. So in phase 2, we want to understand our data requirements, also our data sources. Where is this data coming from? Do we have access to this data? Is it going to be in-house data? Is it third-party data? We also need to be understanding our data quality, because we know that we need good quality data and not all data is created the same. And also our data environment. And then in phase 3, now we're going to be addressing data preparation. So this is our data collection and ingestion. We're going to be cleaning this data. We're going to be preparing this data, deduping it if needed. And we're also going to be labeling and annotating the data in this phase.
So as mentioned, CPMAI, which stands for the Cognitive Project Management for AI Methodology. It's a framework, it's a methodology, it's an approach. I think that's sort of the challenge with the English word methodology. It means some things to different people. And the whole idea is that these are all highly iterative phases. So when we realize that there's a problem, let's say we realize in phase 2 that we don't have a sufficient access to the data, or that, as mentioned in phase 1, we have to identify what pattern we're solving. If we realize that, hey, we can't actually do that pattern because maybe we have data quality issues, we don't just keep going. We go back and say, well, maybe we should consider a different pattern. Maybe we need to consider rescoping. Maybe we need to consider accessing different data or generating data, or maybe now we need a different project, something like that. So that's how these phases work. Now, assuming we've sort of gotten through those first 3 very, very, very important phases, determining what problem we're solving, what pattern we're going to implement with this iteration, and what the data is available to support that pattern, and then preparing that data so that we can support the implementation of the pattern, then we can get down to making our AI system work. This is where we could start using all this fabulous technology that's out there. We could figure out how to build the model or use somebody else's models, which is in the case of, say, generative AI or foundation models. or tune them or enhance them or combine them together into ensembles. But because we already know what problem we're solving and what the constraints are on that problem, we should be a little more successful here than just starting with that and then later figuring out how to adapt our problem to the solution, which never works, right? So in the fifth phase, phase 5, we're looking at now, before we put this implementation into production, now let's evaluate it. This is where the pilot comes in handy. I should have real world data. I should have my real world interactions. Now I need to check how it's performing, not just at a technology level, accuracy and all those measures of model performance, but also at the objectives level. Is it actually, if I said that my objective was to reduce the amount of time somebody was spending, am I actually reducing the amount of time that they're spending? If I want to increase accuracy, am I increasing accuracy? Am I reducing a resource cost? Am I actually improving compliance? People somehow skip answering those questions, because if the answer is no, then kind of like, what are we doing this for, right? So if we can show that, then the next phase, the final phase, is putting this out into the real world. But doing so, we know that models change. We know that data drifts and model drifts. So we actually are going to put it in along with a monitoring and managing framework. Could be technology-based. It could be process-based, process plus technology, people, process, technology, a combination of all those things, where we're going to constantly look at it, see how it's performing, spot check it. If we're using a chatbot on our site, maybe there's some visibility into how these chats are responding. Maybe we put in some guardrails that say that any time a chatbot talks about giving a refund, charging a cost, some sort of fundamental policy, we make sure that the chatbot has always inserted that please, this answer must be verified against someone before you can use it. The answer, I'm not entirely sure. It's possible. Whatever. This is how Air Canada would have gotten out of trouble here if they had put that in their process. And then at the worst case that happens is someone has to interact with a human, right? Big deal to get a problem answered. But people like that. So this is sort of how the CPMAI process works. And it may seem fairly straightforward, and hopefully it does, because there's not a lot of magic here. So we want to map this to maybe what you might be already familiar with in the PM body of knowledge here.
Exactly. So we want to say, how does CPMAI map to this? Because it is complementary. So in the initiating phase, it maps to CPMAI phase 1 with a focus on initiating AI projects. And then in the planning phase, this is also going to map to CPMAI phase 1 on establishing that AI go, no go, and also your project scope as well. We get asked a lot about scoping. And it also will map to CPMAI phase 2 around data understanding and planning. The executing is going to map to CPMAI phase 3 on data preparation to meet those goals, and also to phase 4 on executing the model development. Then when we have monitoring and controlling, this is going to map to CPMAI phase 5, which is going to be on evaluating and monitoring those models that we talked about. You want to be evaluating and monitoring them before you put them into the real world. And then the closing is going to map to phase 6, which is on operationalizing models. And that is where you put the model into the real world.
So if CPMAI may be new, which is it maybe for many, although it's been around now since around 2017, many organizations have certified and put their folks through the CPMAI process. There's basically a training that you can do, which obviously dig into each one of these phases in much greater detail. And we offer some certification for folks who do it. So that way, if you're hiring someone, but you want to manage and run an AI project, having that CPMAI badge should at least give you some understanding that they have some knowledge on how to run and manage an AI process, right? So it's been broadly adopted a lot in the public sector. So we work with a lot of major government institutions, both on the defense and civilian sectors across the world. You can see here, I think Australia's in there too, UK, a bunch of European agencies, and of course American as well, and Latin American as well, and Australian, and a few others. I think I might have repeated myself there. And also, this is meant to be highly iterative, highly agile. And so, it extends CRISP-DM, which has already been around for a while. There's a big workbook that comes with it that you should take to your project. So it's really meant to be directly implementable. And the workbook has questions that need to be answered for each iteration phase. And if you're interested in getting trained and certified, you can go to our courses site. It's a self-paced training and certification with a certification exam on the end of it. That's also online, so you can use the certificate coupon code PMI 2024. You can get 10% off any of those CPMAI certifications. And then, of course, we do have a free option. So if you're just interested in learning more about CPMAI, just for your background, we have a free Intro to CPMAI course. It's about 3 or so hours. You get 3 PDUs as well. It'll provide a high-level understanding of the 7 patterns of AI, an overview of the CPMAI methodology, also self-paced. We've put a lot of people through the intro course. There's a lot. Every day I look at like so many people are taking it, which is great. We want people informed and notified. Our job is to inform people that there is a methodology, that you should not invent one yourself, and that it should really be data-centric and vendor neutral. So so go to aitoday.live/CPMAI. That'll be a direct link there, or the QR code, which will take you there as well. I guess, I haven't seen a lot of questions come through, so I would have stopped and asked them, but like we're here for you. I know there's only a few more minutes left in the meeting, but we're here for your questions if you have any right now.
Yeah, absolutely. Please do type them in. You can also reach out to us. You can go to our website at cognilytica.com. You can reach out to us on the email team@cognilytica.com, or connect with us on LinkedIn. You can connect with both me and Ron personally, and you can also reach out to our Cognilytica page as well. And we had mentioned a few times our podcast, so if you'd like to listen to the podcast, go to aitoday.live and you can check out all of our episodes. You can also subscribe on your favorite podcast provider. We publish twice weekly, so we just published a podcast yesterday and we have another one going out tomorrow.
Yeah, so any questions, or Luigi, you have anything you want to add?
No, thank you, guys. It has been wonderful to listen to you. At least personally, I think this is really, really valuable. Personally, I'm involved in some projects, and today I learned a lot about its phases, and I believe that I've been following pretty much similar approach, but knowing the background on where this comes from and the support that actually you provide in terms of certification and structured approach, it's really great to listen to. But I would like to see if there is any question from the audience. Anybody, if has any question, please just come on mic, or you can just type your questions in the chat.
Okay, great. Yep. Well, as mentioned, you feel free to reach out to us afterwards, or if you want to reach out to Luigi and you want to send out questions our way, either way, happy to address your questions.
Okay, that's very good. That's very good. So for those who might also would like to get videos out of this webinar, I'm going to share the link of the form that once completed will get access to the PDUs that you can use and add to your certification. I think, guys, it was really, really, really interesting. At least my side, I really want to congratulate to the way and that actually the pace and the rhythm that you guys have shared this with us. So one thing that actually you missed to say is about your podcast, and I already subscribed to your podcast because it's really, really interesting, not only for the methodology part, but in case you're new to the Gen AI or AI in general, you cover also the starting points from where actually everybody needs to possibly know. And it could be, while you walk around, you might just listen to Ron and Kathleen discuss it in a very friendly and simple way on how they present AI to the masses. So,
well, thank you. And yes, we try to keep them to what we used to be commute time, now some people's exercise time.
I put the link in the chat just now if you want to go there directly. And also, we will make the slides available for this presentation to you, Luigi. So if you want to share them with everyone, you're welcome to do that.
That's great. Yes, well, I think we will do it. We will put it in the newsletter as well for our members, so that might reach out to you, and your contacts will be there.
Perfect.
All right. Well, thank you all so much. We really appreciate you all being here and participating.
Yes, thank you.
Thanks a lot, guys. Thanks a lot, and I think